So what is XML? Now, XML has been around for a long time. I, unfortunately, will date myself here, and I'll say I remember when XML first came out. It stands for, it's really the X in extensible. It stands for Extensible Markup Language. And the idea is that it is a markup language like HTML, or Hypertransfer Markup Language. And the idea was that what you could put into it was not fixed. So it's designed to carry data. Now, HTML or XHTML, things like this, they focus on how the data looks, right? But XML is just defined to carry the data back and forth. But the extensible part, the part that allows it to be used however you want, is that you define your own tags. So HTML, for instance, has the tag of, I always think less than, HTML, greater than. Okay, and then we have to have an open tag and a close tag. Okay, and then we have, let's say, less than, body, greater than. Right. So those are very fixed tags in HTML. Whereas XML, we can completely use whatever tags we like, as long as we, more or less know on the other end what's going to be using them, or we publish some sort of framework so that anyone else that's using our XML knows what they're getting and how to interact with it. But the idea is that it's designed to be self-descriptive. You can call things whatever you want. Within, there are some structures and guidelines on what kind of characters, what kind of ASCII characters you can actually use. But as long as you follow those guidelines on what kinds of characters you can use, how you format them and what you call them is up to you. So here's an example, for instance. Whereas with HTML, we might have an opening block for HTML, and then a hierarchically sub-block of body. And we also, with HTML, have close network elements. But we still have that with XML, but notice we're creating whatever we want. So the name here is opening element is network, and the close is /network. We have the opening element of CIDR, or classless interdomain routing, and we have our value. Okay, so the value of network is all of these hierarchically sub XML elements. Okay, so CIDR, ID, label, and all of their values and their close elements. So that is the value of the key network, is all of these sub-elements. The sub-element CIDR is its own key, and the value, to pair the key value, is the actual IP address, the classless interdomain IP address, 192.168.0.0. It's actually a network prefix, right? /2024. Okay, we have a UID or UUID, or universally unique identifier, and we've got some sort of a label, okay, super private XML. So we can do whatever we want there. So XML does not do anything. Okay, XML is a self-descriptive format for carrying data, but it's just information with tags. It needs some sort of other program to send, receive, and then trigger actions or do something with that. And the tags themselves, as I mentioned, are not defined by any standards other than what types of values or what types of ASCII characters you can and cannot put in them. But essentially, you can create whatever you want. I could create the opening to be Mark Snow, and I'd have to have a close Mark Snow, so the architecture is defined, but the values that I put in there are not. And then I could have, my first name is awesome, and then what is, then I put in my first name, Mark, or whatever. So I can create both the keys and the values however I want. Okay, so let's contrast that with a different type of serial data carrying format, which is called JSON. JSON stands for JavaScript Object Notation. Now, you might think, well, wait a minute, I'm not using JavaScript as my scripting or programming language. I'm using Python, or I'm using Ruby, or I'm using Go. It doesn't matter. You could use C++, you could use whatever you want as long as it supports JSON, and I'll tell you, almost everything does today. You want to use Java? Great. They've got some amazing tools for JSON in there and for XML. So again, it's just a data format that uses human-readable text to transmit data objects consisting of these key value pairs or attributes and their values. Okay? So it's easy for machines or applications to parse or kind of like piecemeal through. Okay? We talk about parse, we're talking about kind of having something read through it and make sense of it. And we can also generate this very easily as well. So it's built on these two structures, the collection of the name and the value, or the key and the value, or the attribute and the value, whatever you want to call it. But these are the pairs. And they're an ordered list of values. So for instance, that exact same thing that I had created before, and this is a little bit more pretty printed, is, and we do use, instead of like less than and greater than here, we use curly brace. So we use an open and a closed curly brace for the main section. And within this main section, and everything is hierarchical, we then have the key of network. And notice we don't have any close, okay? Like we did with XML. We sort of do in the sense that we have we opened with this curly brace and we closed with a curly brace. But we don't have kind of like a network and then to end a / network to close out that section. Okay, so it's very different in that way. In fact, actually looking at the innermost hierarchical kind of helps you see this key value to begin with easily. And by the way, we do always use, even if we're going to treat these as integers, within JSON we always use double quotes or single quotes, doesn't really matter, but we use strings. So we have our key or our attribute or our name. Okay, if we want to call this the name, that's fine. If we want to call it the attribute, that's fine. If we want to call it the parameter, that's fine. If you want to call it the key, that's fine. But yes, it's all of those. Okay, so the key or the attribute or the parameter or the name is CIDR, and it's in a pair of single or double quotes, this case double quotes. And then we have the colon, which pairs it up with its value. So the value is also a string, and it's 192.168.0.0/24. And then at the end of that, if we want to go on to another key value, we have to put a comma. And again, this does not have to be a new line. So it does not have to be a carriage return. It does not have to be a new line. It does not have to be a line feed. It can be all in one long line. It's serial data. The computer, the application doesn't care. We like to put it on a new line because it's human readable. And that's the pretty print of everything and the indentation of everything. Okay? And almost all modern text-based, what am I trying to say? Text-based tools or, well, anyhow, like for instance, Notepad++, TextEdit, BBEdit, my favorite is Sublime Text. All of these have a pretty print function, or at least have the ability to add in a module for the pretty print function. And so you can just quickly throw in anything that's XML or JSON and click your either keystroke or go up to the menu item if you're super slow mouse user, just kidding, and pretty print this. Okay. So at any rate, notice then we have the second key. Actually, this is technically the third key. So CIDR was the second key, and we'll come back to the first. ID was the third key, which is the value is our UID here, and then comma, because we're going to have another fourth key, which is label, and then colon, giving a one-for-one association from the key or attribute to the value, which is super private XML, even though it's now not XML, obviously. We just use the same data. But notice there's no comma there at the end because we don't have additional keys and values. Okay, so why was this number 2, 3, and 4? Because network was number 1. Now what's the value of network? Well, instead of being in a pair of single or double quotes, it's another open curly brace, and then all of this information in the middle, and then another closed curly brace. So the value of network is all of these sub-keys, kind of an array of multiple values. Okay, but it's all the one value related to network. So if we queried for network and we said, show me everything in network, we would see CIDR and 192.168.0.0/24, the ID, the label in super private XML. We'd see all of that. Now, if we just said show me CIDR, we'd only see this information. Okay, so what is JSON-RPC? Now, I'll tell you, we're not going to spend a lot of time talking about JSON-RPC because this was more important previously than it is now. Okay, so this was more important with the Nexus 9K in standalone mode, but now the Nexus 9K, so I guess I should originally say the Nexus 9K in ACI mode supports full RESTful API because you're not talking to the switches at all, you're talking to the APIC controller, or Application Policy Infrastructure Controller. The Nexus 9K in NXOS standalone mode is, or was, you interacted it with something called JSON-RPC, not with REST. However, today, and for quite some time now, we have had native REST interaction. So we can use REST and call JSON, or we can use REST and call XML. Take your pick. But we used to have to interact with the NXOS through JSON-RPC. So JSON-RPC, it's kind of like REST, but it's not, right? So we have Captain Piet from Star Wars, and we have Benjamin Linus from Lost. They both look pretty close. They almost look all identical, but they're not the same person. Totally different person, right? Doppelganger, but not the same. Okay. So here's how they look kind of alike. So for instance, the Cisco CSR Cloud Services Router 1000V, which runs iOS XE, this is REST. Okay, we have a key and a value, key and a value, key and a value. JSON-RPC, and it's not even just that it doesn't have nested or keys that then call arrays of multiple sub-values in a hierarchical fashion. But JSON-RPC, for instance, in the older Nexus 9K standalone, what was called the NX API, notice that we have this opening key called JSON-RPC. So it looks like it's formatted in JSON format, and it is. But it's called JSON-RPC, and it gives you the version. So 1.0, 2.0, the result, and then the body. And the body is actually where we have kind of more of the JSON data, whereas a traditional JSON file, all of this is the data. Okay, this is all the body. This is all the body. Here, we don't get to the body until this section here. And the first two essentially are kind of defining the interaction with the rest of the body. So for instance, with REST, we have many different URIs, or if you want to call them URLs. So for instance, here's the IP address of maybe my device or web server, 172.6.1.118 / and most people put their API after a subdirectory called API. And then I have, / API v1, and then / global / banner. I have again 172.6.1.118 / API / v1 / global / hostname. And again, this whole prefix and then / global / reload, this whole prefix / interfaces. So this is, for instance, how the CSR 1000V deals with it. If I want to get to NAT, I call the IP address of the CSR / API / v1 / nat-svc, or NAT service. If I want to get to the interfaces, I do that whole thing, IP / API / v1 / interfaces. With JSON-RPC, we basically have the IP address and the top level. And again, this was the Nexus 9K before it supported RESTful API, which it does now. So the reason I'm pointing this out is, one, it's good to know about. Two, you may see you probably will at some point run across documentation. I don't want you to be confused. And then also, you may very well need to interact with or work with a device that is pre the Nexus 9K codename was called Camden. So you may be working with the original 7.0 or 7.1, which was codenamed Bronte or Bronte Plus. But if you're working with 7.2 and beyond, the Camden release, you have a full RESTful API. Okay? So REST uses different standard methods like get, put, post, and delete we talked about. JSON-RPC, that method is something like CLI. Okay? And we'll actually take a look at how to go into the Nexus 9K, turn on NX API, and look at what's called the Developer Sandbox, which makes it ridiculously easy for anyone to learn both programming and also how to interact with a Nexus 9K, either in a RESTful state or a RESTful API, JSON-RPC if you're working with that older code. So what is Python? And again, there are many other languages we're not going to go into. If you want, please look into those. I love Ruby. Go, I'm quickly becoming really, much more, I wouldn't say in love with, but I'm in like with. We're kind of still courting, still dating. Java is incredibly powerful, but also a lot more complex to learn all the structures and classes and things like that. But Python is by far and away one of the most used programming languages, at least in relation to DevOps, in relation to cloud-based architectures. So for instance, OpenStack is written entirely in Python. Whenever you deal with Cisco ACI, if you want the RESTful API, you can use that, like we said, from any programming language. If you want what's called the native SDK or the native software development kit, that is written only in Python. So you can interact with ACI from a RESTful API perspective from any language, just to reiterate. But if you want to use the native SDK, that's all Python. So what is Python? Well, it's a general purpose programming language. It's a high-level programming language, meaning that we don't need to get into the low-level components of system. I don't have to, like I would in C or C++, allocate memory chunks on where to store. I don't have to then, when I'm done using that information, go back and clean that up, a process called garbage collection. Python does that automatically. I don't have to deal with drivers directly. I can do things from a very high level, abstracted from the hardware. It doesn't matter what I run it on. It's going to run the same on everything. It's object-oriented. It expresses the concepts that I want to get across in much fewer lines of code and emphasizes code readability. I would say that Ruby does an even better job of that. And it has the ability to have interactive prompts with the user if we want to. It includes language constructs such as loops, conditions, methods, classes, objects. So all the things that we'll talk about in the Python for the introduction to Python for network engineers, and then our advanced Python for network engineers courses coming up. And I do have a robust selection of libraries. So people have written thousands of existing Python programs, and I can call on those. I don't have to reinvent the wheel, okay? So if I want to, for instance, PrettyPrint is a great example. If I want to format the JSON data that I get back from a APIC, ACI controller, and I want to format that in a very human readable way and print that out to the screen, well, print is something that is there by default, but PrettyPrint is not. But I can simply say, as long as I've downloaded it to my Linux box or Mac or Windows or whatever I'm using, as long as I've downloaded that Python module, or it may even already be installed on a lot of distros, I can just say import at the top of my program, or whenever I need to use it, doesn't even have to be at the top. I can just say import PrettyPrint or import pprint, and then I can use that. So I'm basically saying here's another Python module, or basically here's just another Python file or program or source code file. And when I import it, it basically imports all of those functions, and then I can just call them. I could say, for instance, pprint.pprint, and then what it is I want to print, the variable or the string, and it will PrettyPrint all of that. So that's an example of a module. So as I said before, okay, but why Python? Well, so the NX OS CLI has no advanced language constructs of its own, but Python does provide that. And in fact, I'll give you an example of how I used the on-box Python software to basically create a solution for a customer that we were going to potentially lose a sale to because we couldn't provide a really fundamentally important required feature that they needed. So I'll show you this quick Python program that I wrote, and it's high level, kind of from a PowerPoint perspective, it's high level software flow and construct and what it did in order to produce a feature that the customer needed that, in order to go back to Cisco engineering and have them ask, do an ask to get it written, could have taken weeks or potentially months, or maybe they wouldn't have seen enough dollar value behind it and use, and they wouldn't have dedicated the resources, and I might not have gotten it at all. But we were able to take and create this program. I literally did it overnight in my hotel room, just proof of concepted on our own boxes, and then I had, did a lot more advancement later to it, but go back and win this huge deal based on the ability to use the on-box native Python programming language that's included that I can use on any NXOS device. So it's an established, modern, powerful, and clean library, programming language with lots of libraries and liberal license to use it however you want. Other languages may also fit the bill. They weren't chosen for NXOS, so there's really no use arguing it over. TCL is there. Okay, it is there on NXOS. It's always been there on almost every iOS device since I can remember, iOS 11.3, I think. But no one uses it in NXOS like they do Python, unless you don't know Python and you know TCL or tool command language. Okay, the license that Python uses, the GPL license, or very like, has very few restrictions on modification, distribution, and commercial use, which makes it very attractive to embed and distribute new functions without worrying about having to pay royalties or copyright. And there are a lot of on-box applications in the NXOS device, like Embedded Event Manager, Power on Auto Provisioning, that you can use to call Python scripts. In fact, in the example that I just kind of gave, and I'll show a little bit later, of this tool that I used to take down this big deal to provide this function, Python was great, but I needed it to start at command line, I needed it to start at boot up. But I not only needed it to start at boot up, I needed it to start only once something had occurred. So I needed there to be a data plane not only on the box itself, all the modules on the 9508 to have loaded and come to a full powered on state, but I needed also, specifically, I needed BGP adjacencies between my VXLAN leaf that I was running this on and the spines, because I needed to guarantee that the network was up, stable, and functional. So I did an EEM that looked for one of the BGP adjacencies, or peerings, really, to come up. And as soon as that came up, that triggered the Python, which was a constant loop, which just kept looping around and testing to make sure that there was reachability and a not over a certain amount of delay or latency. Okay, so you can create your own scripts that are almost like super commands. You can even create your own command modifiers. So, the things where you do a show run pipe to include, or pipe to begin, or pipe to section. You can do show run pipe to your own Python program if you want, or show anything pipe to your own Python program. So the capabilities, I can't even begin to say, they're just immense. So taking a look at an overview of Python scripting, it can be run in two modes on the NXOS device, which is the interactive Python shell and the non-interactive. And we'll go through this a little bit later. Interactive you would typically use to develop your code and test it, and then non-interactive is when you would have it fully automated and running by itself. Okay, there is a CLI class that you can use within Python to import and then call any CLI commands, and I'll give you an example of that. Like I said, it has integration with Power on Auto Provisioning, Embedded Event Manager, and the scheduler. The resource usage is capped, so it won't kill the box. It does run at the lowest priority level, so again, you're not going to kill your box. And you do have restricted access. You do have security that is there to protect you so that you don't kill your box. So for instance, the interactive Python shell, and this is the same from Linux, from Mac OS, and if you install it in Windows, or from the NXOS, which is really Linux on any Nexus 5K, 9K, 7K, 3K. So all you do is type Python. And Python 2.7 is what most people do still use. We'll talk about various versions later. There is Python 3.x, but most people have not yet adapted their code, and there is significant enough changes that I would say if you're learning a language, learn 2.7 to begin with. Learn X later if you want to go above and beyond and you know you need something that 2.7 just doesn't provide. Okay, so type Python, and all of a sudden you're in this interactive interpreter. Loads some code giving you license information, and then basically it says, okay, you're running. And you can type anything you want. The difference between that and running, for instance, the command Python to kick off a program and telling it where the program is, boot flash, colon, and then the name of your program, showbuffer.py, where it runs, executes, and returns your information. There's also help in Python on Box NXOS, so I can type help and then parenthesis, and then whatever class it is or whatever NXOS command or command type class I want to call. And for instance, this class PTP, it will show you, you can use it to enable or disable precision time protocol, what the built-in features are, the inherited methods, and how these work. And of course, you need to know a little bit about Python to use that, but the idea is that you can get help on any class.